Hello, my name is Luis Salazar, and I will be solving these three problems. So the first problem we have to do splitting. We have to split the fraction, and as we can see, we can split this in half. So we have the integral of 4 over e to the power of 3x, but we can change that as if there's exponents in the denominator, they're negative in the numerator. So we're just going to change that to 4 times e to the power of negative 3x plus um, e plus the integral of e to the power of 5x over e to the power of 3x. Again, we're going to do the same thing. So it'd be 5x minus 3x, so that would just be the integral of e to the power of 2x. And these are all to respect to x. I forgot to write that. So now we just have to find the antiderivative, and here the antiderivative, to find it, you have to multiply by negative 1/3, so that would be negative 4 over 3 times e to the power of negative 3x. And then the same thing for here as well, you'd have to multiply by 1/2, so that'd be plus 1/2 times e to the power of 2x. And then we can't forget our c. So this is our answer for number 1. Okay, for number 2, we have to do the integration by parts. So we have to think of limit. Um, so here we have a polynomial, which stands for the p, and then here we have an exponential, which stands for the e. So here in limit, p comes first, so our u is going to be 3x, our du is going to be 3, and then our dv is what is left, which is e to the power of 7x, and then our v is the antiderivative, so you have to multiply by 1 over 7. So our v is 1 over 7 times e to the power of 7x. So in order to do this limit thing, we have to know the formula for it. So it would be the integral of u times dv, that's our u is 3x, and our dv is e to the power of 7x, is equal to u times v minus the integral of v times du. So we know our u and our dv and our du and v. So we just we can just plug in. So our u would be 3x. Our v would be 1 over 7. It's a 7. E to the power of 7x. Minus the integral of v, which is 1 over 7. E to 7x times our du, which is just 3. So we're going to do some mental math. It's not that hard mental math, but we multiply these together, giving us 3 over 7 times e to the power of 7x. In order to find the antiderivative of that, you would have to multiply by 1 over 7. So 3 over 7 times 1 over 7 gives us 3 over 49. So we're just going to bring down everything else. So it'd be 3x times 1 over 7 e to the power of 7x minus, what did I say? 3 over 49 times e to the power of 7x plus c. We can't forget our plus c. And that is our answer for number 2. Yeah. Um, oh, let's get that. So for number 3, we have to use the Pythagorean identities. So here, we're going to keep the sign, and we're going to split apart that cosine and then use the identities um, to then distribute and then use u substitution. So we have the integral of sine 7, that's a 7, x times, we're going to split this, whoa, squared x times just regular cosine, and then with respect to x. So now use the identities to change this cosine squared. So the integral of sine x, 7, can't forget 7, times 1 minus sine squared x times cosine x with respect to x. So now we were going to distribute this sine to both of these, giving us the integral of sine, that's 7, times cosine with respect to x. These are parentheses. So now we can use u substitution. Our u is going to be our sine of x. Our du is going to be cosine of x. So now we have 2 u's times our du, which is fits perfect. So now we don't have to focus on this cosine. Now we can now do the integral of u to the power of 7 minus u to the power of 9 times, times du, which fits perfect. So now we just find the antiderivative. So this would change to 1 over 8 times u to the power of 8 minus 1 over 10 times u to the power of 10 plus c. And now we just plug in our u, which is sine of x. So that would be 1/8 sine to the power of 8 x minus 1 over 10 sine to the power of 10x plus c. So this is our answer for number 3.